Subscribe now and click on the bell icon to never miss learning from Vedantu.
Okay guys, the name of chapter is Theory of Equations. So as the name suggests, we will be dealing with many equations. Quadratic, reducible to quadratic, that is initially not quadratic but it gets reduced to quadratic. Then cubic, biquadratic. Biquadratic means 4-degree equation, etc. And some aspects related to them. Not only their solving, okay? So we will be studying these things in this chapter, Theory of Equations. Primarily almost everything about equations, how to solve them, some other conditions related to their solving, their graphs, and considering two equations together, seeing relation between them, and so on. Too many things. So after this chapter, what output we should expect is, given any equation, I should be able to handle it. That is expectation. And when I say handle it, means not only solving, anything related to that equation, we should be able to handle it. So guys, let me start with a very basic term. Whenever we talk about theory of equations, it is primarily algebra, which we are talking about. Okay. So when algebra comes, the first term that comes to mind is polynomial. Maybe algebra starts from polynomial only. So first thing is, let me just check how many of you have just prepared polynomial. Do not tell me your answer, just read the question. I'll give you the poll. There you fill your answer. Question is, which of the following is not a polynomial? You need to tell me which one is not a polynomial. Just have a look, think about your answer. You have to tell me which of the following is not a polynomial. Guys, first of all, answer is C. I'll come to the reason later on. First of all, you also tell me the answer to this. You need to tell me which of the following is a polynomial. Now you need to tell me which of the following is a polynomial. Root of 11, 1 by x plus x, x power minus 2 minus 1, root x plus x. Which of these is a polynomial? Answer is root of 11. This is the right answer. So guys, okay guys, now let me explain polynomial. What is a polynomial? First of all, as they define it in your books, expression of this form. Is called a polynomial. And they also mention is called a polynomial of degree n. Now, when I say expression of this form, what do we actually mean by that? Number one, powers or indices are good. By good, I mean they are whole numbers. A0, into x bar 0. Try to see, a naught is just like a naught x bar 0, constant term. Then a1x, then a2x square, then a3x cube, so on to an x bar n. Second criteria, there is one more criteria. But before going to second criteria, using only this criteria, let me just come back to previous two examples. Here this is not a polynomial because power is negative. Polynomials mein power cannot be negative. Power have to be whole number. 0, 1, 2, 3, so on to like that. And here it is not a polynomial because of 1 by x. 1 by x mean x bar minus 1. Again power negative, so it cannot be a polynomial. Again power negative, cannot be polynomial. Root x. Root x is x bar half. Power cannot be fractional also. Power has to be only whole number. 0, 1, 2, 3 like that. So because of this half power, this is not a polynomial. This is a constant polynomial. It is a polynomial. Constant, if you want to write, you may write into x bar 0. So it's a polynomial of degree 0. So A is a polynomial. Coefficients can be anything. Okay. There is no restriction on coefficients so far. A0, A1, A2 can be anything. To be precise, they take it real numbers. Yes. Okay, so AIs can be anything. This is first criteria for polynomial. And second criteria, which is even more important, sometimes there must be one highest power. Now, what do we mean by that? By that I mean x plus x square plus x cube plus so on to. Just going on. It's not stopping anywhere. Is not a polynomial. Because it does not have any highest power. Try to see when they say expression of this form, it means it has to stop somewhere. And that highest power is called degree. It has to stop somewhere. It cannot just go on and go on and go on. So clearly this x plus x square plus x cube and so on is not a polynomial. So now onwards, definition of polynomial should be very clear. All the powers should be good. Good mean whole number. And there must be one highest power which will be called degree of that polynomial. Nothing more than that on polynomials definition for the time being. Obviously, I'm not expecting any doubt on that. So moving ahead. Next, depending upon degree, we have kept few special names. Okay. And I am pretty sure you must be familiar with those names. When degree is 0, we mean constant polynomial. We name it constant polynomial. It will be of the form one constant, one number, and that's it. When degree is 1, we call it linear polynomial. It will be of the form ax plus b. There will be one constant term and one term containing x. When degree is 2, it's called quadratic polynomial. Very good, Sundar. It will be of the form ax square plus bx plus c. Similarly, for n equal to 3, we call it cubic. For n equal to 4, Sundar, that's completely fine, beta. You need not write everything. For n equal to 4, it's called biquadratic. So that much naming you should be knowing. Okay. More than that is not required. Even I don't know. Okay, guys. Now, certainly our focus is on quadratic equations. An equation of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers and a is not 0, is defined as quadratic equation with the real coefficient. Because a, b, c, we have taken coefficients to be real. Why a is not 0? Because if a is 0, then this term will vanish and it will no more be a quadratic. So certainly a should be non-zero. Clearly this is quadratic, this is quadratic. This as such is not a quadratic because 1 by x is there. Okay. But it is reducible to quadratic just by taking LCM. Nothing more than that. So taking LCM, it will be x square minus 2x plus 1. This terminology will not be used anywhere as such, but just for reference sake, should be knowing these basic things. Guys, again, this is very basic. I'm not expecting any doubt here. Then, fundamental law of algebra. This is a statement which you have to accept without proof. Any polynomial of degree n has n roots. Okay. For example, this is a 3-degree equation. It will have 3 roots. It will have 3 roots. Okay. Certainly, it is not necessary that all the 3 roots should be real. Okay. Few might be real and few might be non-real. By non-real, we mean the numbers which are not real. We will be reading such numbers also soon. Okay. Point is, n-degree equation will have n roots. Some of them might be real and some of them might not be real. But number of roots will be n. Now guys, wait a minute, somebody has some problem. Parth, you know that, beta, I cannot do anything in that. I do one thing, I'll just, for little time, I am making chat available to all. There is a guy named Aditya and one is Lijo. Lijo might not be there, but Aditya will be there in this chat section. You just ask him for the help. Okay? He is there to help the students only. That guy is by the name of Budhavaram's Nithya Aditya. So you need to talk to him if you are facing any problem. Okay? Now guys, please do not chat among yourself or I'll have to close it again. There's no hello and hi here. Okay. So there was some problem. Yes, Rishabh Sharma is saying, sir, an n-degree polynomial has n plus 1 terms only. But it need not be. That is like not at all required. For example, this is a 3-degree polynomial, but it has only 2 terms, right? The rest, all the coefficients are 0. So that statement does not really mean anything good. Now guys, slowly let us get into the first major thing which you have done in 9th or 10th class, that is remainder theorem. Yes, Rishabh, you can say that. Now, what is remainder theorem? As such, I was initially expecting everybody must be remembering that, as I asked you to revise all the concepts. But seeing your response for polynomial definition, it's better I just explain this remainder theorem without wasting my time in asking. Okay, so let us guys understand what is remainder theorem. Statement is very basic. If polynomial p of x is divided by a linear factor x minus a, then remainder is p of a. It says if there is a polynomial p of x and you are dividing this polynomial by x minus a, then certainly you will get something as quotient and finally something as remainder. Okay, some quotient will be there, some remainder will be there. This theorem says this remainder will surely be p of a. Simple example. Guys, just pick up your rough copy and divide this by x minus 1. Just do it for me. Just do it completely. Do not use this theorem. Just divide completely. I'm also doing it. No, why will I do? You guys do. Okay. Okay, guys, do it. I just want to ask what is the remainder. So just divide it and tell me what is the remainder you get. Okay, others also quickly. Very good, Rajneesh. Ashish, that is correct. Very good. Very good, Goswami. Nice, nice, Sundar, great. Very good, guys. So you are getting 3. Very good, Janvi, Rishabh, great. So we can find it by dividing it completely. Now this theorem is telling me if you are dividing a polynomial, okay, Vidhi, if you are dividing a polynomial by some linear expression, then remainder of this will be value of p at, you just put this equal to 0. Let me do it here. Just put x minus 1 equal to 0, x comes out to be 1. So value of p at 1. So 1 cube plus 2 into 1 square plus 1 minus 1, you get 3. Straight away. You need not divide it. Straight away you get your answer. So that is a remainder theorem. So whenever you divide px by x minus a, the remainder will be p of a. What is this a? Value of x got by putting it equal to 0. This value of x. Just keep it here. So guys, if we just take few more examples, so I suppose we can do it very quickly now. For the timing I'm doing it, you just wait and watch. I'll be giving you a good question to do. Right now, just let me do it. Find remainder of this polynomial when it is divided by x minus 1. Here is big polynomial. We are dividing by x minus 1 and this remainder is asked. Rishabh, I'll be telling that also. Wait a minute. So my theorem says you just put this equal to 0. Whatever x you get, just find value of p at that x. That will be your answer. It comes out to be 1 plus 3 plus 2 plus 1. Very good, guys. So answer is 7. B part. You just put this equal to 0. Whatever x you get, value of p at that x is your remainder. It comes out to be -1 plus 3 minus 2 plus 1. So this is 1. Similarly, remainder when it is divided by this, you put it equal to 0, x comes out to be -half. So remainder will be p of -half. -1 by 8 plus 3 by 4 minus 2 by 2 plus 1. Whatever it is, this is your answer. Don't worry, guys. Okay. Now, guys, before I give you the logic, or you may say the proof of remainder theorem, just tell me, did you get how am I finding the remainder? Did you understand how am I finding the remainder? Before that, let me just give you the logic behind this remainder theorem. Guys, the logic is very simple. First, let me just somehow mention the theorem here by using some notations. This is a theorem. Whenever we divide p of x by x minus a, remainder is p of a. Now, how to prove it? Some of you got confused with division algorithm. Many of you, when I asked what is remainder theorem, you said division algorithm. Actually, you gave the statement of division algorithm. Division algorithm is different, remainder theorem is different. But of course, the proof of remainder theorem will come from division algorithm. When we divide p of x by x minus a, then we will get some quotient and we will get some remainder. This is the division algorithm, and it also states where degree of remainder is less than the degree of divisor. That is obvious. Degree of remainder will always be less than degree of divisor, degree of x minus a. Now we very well understand that degree of x minus a, no Johnny, it cannot be even equal. If they are equal, you will further divide it. No, you will only stop when degree becomes smaller. So degree of x minus a is 1. So I suppose you can very well understand, then the only possibility for this is 0. Okay, polynomial's degree cannot be negative. So if degree of Rx is less than 1, it means it has to be 0. So therefore, P of x is x minus a into quotient, whatever is the quotient, I don't know what is the quotient of course, plus remainder. Now as remainder is of degree 0, it means remainder is constant. So in spite of writing it r of x, let me just use r, because I know it is not depending upon x, it is a constant number. Okay, so now my job is to find this number. That is what we want, and we want to prove it is p of a. Guys, here you need to understand one thing and complete matter will be sorted out. When I say P of x is equal to this, it means they are equal for all values of x. Yes or no? Because I am saying P of x is equal to this. I'm not asking when it will be equal. I'm telling they are equal. And when two things are equal, it means they are equal for all values of x. Just like x square minus 4 is x minus 2 into x plus 2. Here I'm telling you they are equal. I'm not asking you whether they are equal or not. And when I'm telling you they are equal, it means they are equal for all x. Whatever x you take, it will come out to be equal to this. So why I'm putting stress on that? Because my next step is putting x equal to a. If they are equal for all x, they must be equal for x equal to a also. So in particular, when I put x equal to a, we get p of a. Now this term becomes 0. And that is the only reason I chose this x to put, because I wanted r. For that, I wanted to eliminate this thing. I want to just take it away. So moment I put x equal to a, this becomes 0 and my job becomes easier. So 0 plus r. So what is the value of r, guys? P of a. And that is what I wanted to prove. That my remainder is P of a. Just have a look. 30 seconds for you now. Anybody, any doubt? No, Rishabh Sharma, this theorem is not valid for 2-degree polynomial. It is only defined or like valid for linear divisor. Whenever we divide by a linear factor, only then it is applicable. Okay, Anirudh, I'll do that. Okay, so no more further doubts. So let me just conclude it once again and then we'll move ahead. First of all, what is the statement of theorem? Statement of theorem is whenever we divide a polynomial p of x by x minus a, then remainder comes out to be p of a. That is the remainder theorem. That my remainder will be equal to p of a. And we verified it through some examples also. Now here is the proof. Now proof basically starts like we are dividing p of x by x minus a and we want to comment on remainder. So division algorithm was the only thing to start with. So I said when I divide px by x minus a, I get some quotient from remainder. So I write p of x as x minus a into q of x plus r of x. Here q and r are the remainder. Quotient and remainder. Now, it is a very crucial part of division algorithm. It also states degree of remainder is always less than degree of divisor. And it is very obvious because if remainder's degree is more than degree of divisor, it will further divide. No, it will not stop there. So now, degree of divide is 1. Now, degree of has to be less than 1, so it can be 0 only. It cannot be anything else. Now if degree of Rx is 0, it means it's a constant polynomial, constant number. Denoted it by R. Rather than saying it R of x, I just called it, it's a constant number. Now from here, I wanted to comment on, and Aisha, I don't expect that doubt. This is really not good. Degree of x minus a is obviously 1 beta. What is the highest degree in this expression? It is 1. What was that doubt? Okay. Now, I was interested in finding r And this was the term which was like disturbing me. I didn't want to have this term. So to remove this term, we put x equal to a on both sides. So as soon as we put x equal to a on both sides, this term becomes 0 and you get the value of r as p of a. That is remainder theorem. Okay guys, so this was remainder theorem. We also did few examples of remainder theorem and we saw we could find the remainder very quickly. Now guys, next is factor theorem. Before starting with factor theorem, I need to ask you one thing, beta. Let p of x be x square minus 5x plus 6. Okay. Clearly you can see p of 2 is 0. So can I say 2 is root of px? Yes or no? Can I say that? Very good. Because that is something we have studied. Root is something which like put and it becomes equal to 0. Very good. So I can say if p of a is equal to 0, then x equal to a is part beta. Try to understand how can I help you with that, no? If you are facing some issues with connectivity, then I cannot help you with that. Either you have to like check with your connectivity thing, or you have to change your Wi-Fi connection, or you have to refresh. How can I help you? You are again and again telling me that. Okay, so if p of a is 0, then x equal to a is root of px. Anybody having doubt in this statement? Before proceeding ahead, I need to be confirmed that you are comfortable with this statement. Everybody just tell me, are you comfortable with this statement that when I say p of a is 0, then x equal to a should be root of px, as I concluded here? Okay, so it's like pretty much everybody is clear with that. Great. So now proceeding with that, this is a statement of factor theorem, that if p of a is 0, then x minus a is factor of px. Of course, it is if and only if. If and only if matlab this implies this and this implies this. In polynomial p of x, p of a equal to 0 if and only if x minus a is factor of px. This is a statement. Now let me just simplify it for you. I just concluded p of a 0 means x equal to a is root of px. That is the meaning of p of a equal to 0, is root of px. Now if and only if x minus a is factor. Now this seems a bit easy to comprehend. X equal to a is root if and only if x minus a is factor. That is pretty much obvious. If somebody some equation has x equal to a as root, certainly when we would be factorizing it, one factor would be x minus a, and from there only we would have got x equal to a, like x square minus 5x plus 6. This has root 2 and one root is 3, let me tell you. Now it is pretty much obvious when we will be factorizing it, one factor would come out to be x minus 3 and one factor would come out to be x minus 2. From here I would have got 2. From here I would have got 3. So clearly if 2 is root, x minus 2 must be factor. If 3 is root, x minus 3 must be factor. Only that is why they are roots, no? From there only we got these roots. So that is the approach to understand this factor theorem. Okay guys, so today onward how I will be stating this theorem is A is root if and only if x minus a is factor. Okay, so a is root, then x minus a is factor. X minus a is factor, then obviously a is root. Now guys, let us do few examples on factor theorem. First one, easy. You will not do this question, you will do next question. Determine k for which this is factor of this. Easy. Factor theorem. If this is factor, then obviously minus 2 should be root. Now if minus 2 is root, then this should be 0 at minus 2. Let me call this as p of x. Then p of minus 2 should be 0. So it implies minus 2 plus 1 raised to power 7, 2 into minus 2 plus k whole cube equal to 0. So that is minus 1 k minus 4 whole cube equal to 0. So from here we get, let me just do this complete, k minus 4 cube equal to 1. So k minus 4 equal to 1, so k equal to 5. Just have a look, take 30 seconds, just ask me if you have any doubt, because next question you have to do. Yes, just ask me if you have any doubt, because next question you have to do. Beta, no, don't do that, beta. If x cube is 1, then x is only 1. It is a case with even powers when we get plus minus, not with odd powers. With odd powers, we get only one value. Okay. So no more doubts, that is great. So primarily, it's very basic. When x plus 2 is factor, then certainly minus 2 will be root. Minus 2 should satisfy. Straight away we get k. Now guys, do this question. I give you hint first of all. Hint is, factor theorem says if x equal to a is root, then x minus a must be factor. And this question is not more than 3 or 4 lines, believe me. Okay guys, now the time is over. More than 3 minutes are passed. Now everybody just stop. Everybody just stop and look how I am approaching this question. After this question, you will be doing next question, okay? It will be bit one level ahead of this question. So just understand this question so that you may be able to do next question. Guys, this p of 1 is 0. What does that imply? It implies x equal to 1 is root of px. Okay, Similarly, P of 2 is 0. Arindam Goswami, that is wrong. This is 0 and this is 0. All these values are given to be 0. This implies x equal to 2 is root of px. This implies x equal to 3 is root of px. And this implies x equal to 4 is root of px. Simple, nothing. Primarily, he has given you, very good Shreya, he has given you 4 roots basically. He has given you 4 roots of p of x. Now, clearly factor theorem comes into play. What does this tells me? It tells me x minus 1 is factor of px. This tells me x minus 2 is factor of px. This tells me x minus 3 is factor of px. And this tells me x minus 4 is factor of px. So if you understand, this statement is primarily giving you 4 factors. Provided you understand factor theorem. Simple statement hai beta. If x equal to a is root, then x minus a is factor. 1 is root, so x minus 1 is factor. 2 is root, so x minus 2 is factor. 3 is root, 4 is root, so x minus 3, x minus 4 are factors. Now if they are factors, then this px, let me just write px only. Arindam Goswami, when I'm explaining something, you better try to understand and don't ask me things in between. P of x, you have 4 factors of P of x. So Px must be of the form x minus 1 into x minus 2 into x minus 3 into x minus 4 into something. It can be of this form only because that is the meaning of factor, no? If x minus 1 is factor, it means P of x is x minus 1 into something. So we have 4 factors. Now you just tell me, what is the degree of P of x? X power 4. Can it have more than 4 factors? Just tell me. Can it have more than 4 factors? No. Very good. When you multiply this, already x power 4 is created. No x more can be there, or it will be x power 5. Very good, guys. So primarily this is your px. Got it? Finished. You no need to find b, c, d and e. No need to find that. We got px and that too in a very good form, factorized form. P of x is just x minus 1 into x minus 2 into x minus 3 into x minus 4. Now what is asked? P of 5. What a big deal. Just put x equal to 5. 5 minus 1, 4. 5 minus 2, 3. 5 minus 3, 2. And 5 minus 4, 1. It is 24. Finish. Take your time now. Just clear if you have any doubt in that, because next question will be elder brother of this. Yes, Rajneesh. That is the power of factor theorem actually. Aisha, you didn't get last 2 steps. Beta, those were the only steps to be like understood. Beta, don't be a bit attentive. Listen. First of all, you need to understand what is this. You have 4 factors of px. Do you think px can have more than 4 factors? Aisha, just tell me. It's a 4-degree polynomial. Yes. So it cannot have more than 4 factors. And the 4 factors are in front of me. So px should be the product of those factors. That's it. No? If I tell you this is a quadratic and x minus 2, x minus 3 are its factors, then won't you say that this must be equal to x minus 2 into x minus 3? That's it. Won't you say it like that? Yes. So here we had 4 factors. So I wrote it like this. So once we have p of x, we have p of 5 also. We just put x equal to 5. Point is, student start thinking about finding b, c, d and e. They don't realize, dear, it's not the simple numbers they have given. P of these numbers is 0. So these are primarily the roots of px. Okay. So if we think in this direction, you need not make 4 equations and then solve for b, c, d and e. You just realize these are 4 roots. We have 4 roots, we have 4 factors, and it cannot have more than 4 factors. Story finished. So guys, now is the turn for elder brother. And certainly guys, because we are running bit out of time, you guys took time to do this question. Oye phete muh beta, mere pyare beta. Don't do this beta. It is such that I am just a bit lazy, so I use such things to save my time or save my energy. Second question I'm giving you right now, but it is your homework, because right now I can't afford to again take 10 minutes on it. Okay. Anirudh. So this is your homework. I'm writing it. You may take a screenshot. If p of x is this, I'm again taking 4-degree polynomial. Such that p of 1 is 1, p of 2 is 2, p of 3 is 3, p of 4 is 4, then find p of 5. Hint is again, लगना तो factor theorem ही है. It will be done by factor theorem only. But now clearly I haven't been given, I'm not given the roots of px. It is something else. But whatever it is very beautiful. Right? Now how to use this thing, I leave upon you. If any one of you requires some hint, I'm not giving answer also, you just take it as a homework.